partial differential equation, engineering problem solving, question number 1. A metal bar of length 0.2 meter is subjected to a temperature of 18 degrees Celsius on the right end and 90 degrees Celsius on the left end. Find the temperature node at location 1 and time 1 inside a metal bar when time is equals to 50 seconds from the range of time is equals to 0 and time is equals to 100 seconds. So for the change in location, you have 0.05 meter, and for the change in time, we have 50 seconds. And for a specific heat, we have 460 joule over kilogram K. So for our density, we have 7,700 kilogram per cubic meter. So for our thermal conductivity, we have 52 W over meter K. So for the solution, so we have to find the thermal diffusivity, which equals to 52 over 7,700 kilogram per cubic meter times 460, which equals to 1.46819 times 10 raised to negative 5 meters squared per second. So we have lambda, which equals to 1.4681 times 10 raised to negative 5 meters squared per second times 50 seconds over 0.05 squared is equals to 0. So lambda is equals to 0.2936. So for the number of time steps, we have the formula of time final and initial time final to initial times over the change in time. So we have the for final time we have 100 seconds. For initial we have 0, and for the change in time we are given 50 seconds. So solving this, we get the number of time steps to 2. So here we have here in the diagram, we have it shows as the time steps of each temperature. So the boundary conditions is for time 0 raised to j is equals to 90 degrees Celsius. For t sub 4 raised to j is equals to 18 degrees Celsius for all j is equals to 0, 1, and 2. So 12 degrees Celsius is the metal bar's initial temperature, meaning all temperatures of the nodes are 12 degrees Celsius when time is equals to 0 except the boundary condition. So for time sub I raised to 0 is equals to 12 degrees Celsius for all I is equals to 1, 2, and 3. So the initial temperature at the node when time is equals to 50 seconds. So rewriting this, we get t sub 1 raised to 1 is equals to t sub 1 is equals to 0 plus initial temperature at the nodes when t is equals to 0. So we write this as t 0 sub 0 is equals to 0 is equals to 90 degrees. T sub 1 raised to 0 is equals to t sub 2 is equals to 0 is equals to t sub 3 is equals to 0 is equals to 12 degrees Celsius, and t sub 4 raised to 0 is equals to 18 degrees Celsius. So temperature at the nodes when t is equals to 50 seconds. So setting j is equals to 0 and I is equals to 0, 1, 2, 3, and 4. So we write for location 1 and time 1. So we have t sub 0 plus lambda. The formula, we have t sub 2 raised to 0 minus 2t sub 1 raised to 0 plus 2 sub 0 raised to 0. We have 12 degrees Celsius plus 0.05 2936 times 12 degrees Celsius minus 2 times 12 degrees Celsius plus 90